Okay, for this part, I need to introduce part of our product. So this is a GCC plugin for detect and recovery a control hijacking attack. And I'll show you some source code and how I use it to act against a buffer overflow that overwrite my return address. Okay, so this is code for plugin. I use RTL pass here, which is the last part of the compiler work, which converts the RTL intermediate representation to our resulting assembly codes. So I insert something to the RTL here, and we finally insert to our assembly. You can see more in our report. And this is the test program, which is the vulnerable program we use in our assignment 1. But unfortunately, I could not spawn a shell in my machine for some reason. Maybe it's because the virtual machine is 32 bits, but my machine is actually 64. So I did change the Python file to make it suitable for my machine to make sure it will override the return address. But for some reason, I just cannot spawn a shell. But I did override the return address. It can be seen in this picture that it did jump to the NOP slacks, but for some reason it is not executable. So let's see. So it will just result in a segmentation fault. We can see that if we compile without the plugin with this command and just run the output file, yeah, we can see a segmentation fault here. But if we compile it with our plugin, let's see what will happen. So first we need to compile the plugin file into an output file. And second, we need to link the .o file with a .so. SO stands for shared output file. That is what we need for if we want to insert it into our test program. Make it act like a plugin. And so finally we add it to our test program. Sorry, just need to change the code here. Oh, sorry. This is normal commands, but as we can see in this command, we need to add something here to make sure the attack will act fine. So this is the right command, actually. Yeah, we now compile the vulnerable program with our plugin. And this is to switch a mode. If you choose 1, it will jump to the static part, which is another part of our project. And if we choose 0, it will come out to our plugin. And we can see that some information from our plugin. And if we run this program, vulnerable program with plugin, we will see it returned properly. And because we have buffered our return address in some place, actually in the main program, in the space for main program, we just make sure a space is just for our return address reserve, and we store it there. And when it was override by program, we just change it back to the original value in our app log of we can see the vulnerable function, the buff. So it turns out it works properly.